Hi, this is Mr. McGovern. This is the 9th video in the electric circuit series where we're looking at electrical power. So we've met power before when we studied mechanics, and power is the rate at which energy is transformed from one form to another. So here we're specifically looking at the rate at which electrical energy is transformed from one thing to another. So that could mean that if we're looking at a light bulb, the rate that electrical energy in the circuit is transformed to light. If we're looking at a speaker, it's the rate at which electrical energy is turned into sound. If we're looking at some sort of resistor, the rate at which electrical energy is turned into heat. So the formula for electric energy, the formula for power is that we learned in mechanics is just the energy divided by time, the rate at which energy is changed from one form to another per second. That's the divided by time. This year we've got in electricity a second formula, which is voltage times current. And I'm going to show that those two formulas are actually equivalent and equal to each other. So we had earlier definitions of voltage, which was voltage is the energy per coulomb. That's the energy per group of electrons. And current's definition is coulombs per time. So how many groups of electrons go past a point in a circuit per second. So if I say that P power equals voltage times current, V times I, and I use those definitions, E over coulombs times, or E over charge times charge over time, you'll see there's a Q, a charge, above and below the fractions, and they cancel out. So I'm just left with energy per time, which is my definition from mechanics. So my definition for power from mechanics, energy per time, is equivalent to voltage times current. Some hints on using the formula, just like with Ohm's law, I want you to add in subscripts. So are you looking at the total power, which is the total voltage and the total current, or just the power over one component in the circuit, like bulb A? So that would be the voltage over bulb A and the current over bulb A. If a question in an exam asks you, hey, which bulb is the brightest? You're going to go through and you're going to work out the power, but you've got to make that link first. And so I want you to start your answer by saying power is a measure of brightness. And if you want to shortcut that, you can just say power equals brightness. Okay, and then you go on and you do your power calculation. So you're linking the fact that you're doing a calculation with what about power to brightness, which they're asking in the question. And the similar thing with if they say which resistor gives off the most heat, or which speaker is the loudest. You do the same thing. You say loudness is a measure, power is a measure of loudness, and then you do your power calculation. And it doesn't matter if it's series or parallel with power, you just add the powers of the circuit up to give you the total. So it doesn't matter, series or parallel, just add up the individual components and they'll give you the total. The last hint is the formula equals VI. We know that also Ohm's law, V equals IR. If you substitute IR into the power formula, so instead of writing P equals VI, instead of the V, you write IR, because that's what we know that V equals, and just simplify that, you get power equals I squared times R. This is the power formula, but it's in a situation if you don't have voltage. So it's a shortcut. And it can often be very easy if you're doing explain questions to just use this formula in your explanations. Similarly, you can rearrange Ohm's law and find current equals voltage over R. Put that into your power equals VI. Instead of writing VI, you're writing V, and then instead of I, you're writing V over R. Simplify that, you get V squared over R. So you've now got three formula to use. Only the first is given to you, but if you can derive the second two, often they are much more useful than the first one, especially when you have explain questions.